Now on number 12, we're asked to find the range of another quadratic. It's a different one than we had on number 11, but it's a quadratic because it has an x to the second power. So again, we know that this is going to graph as a parabola, opened up or opened down. This time we're asked for the range of the quadratic. And remember, we've talked a lot about domain and range of functions. Domain is your x values, whereas range is your y. So we've remembered that because D comes before R in the alphabet and X comes before Y. So domain and X go together and range and Y go together. Now, as far as the domain of the quadratic, since these arrows are showing us this graph is going forever up, it's not going up straight, it's going up at an angle. So it's also going forever to the left and forever to the right. So we always say the domain of a quadratic is all real numbers with that fancy R because it can be anything. But the range cannot be anything. And the reason why it cannot be anything is range is your up and down movement. So, for instance, if you have a parabola open up, it's going forever up, but it's not going forever down. It has this point right here, which is its lowest point, which remember we call the vertex, and when it's at the bottom, it's called a minimum. So in this case, that's as low as y gets. All my other y's are higher than that. If our parabola opens down, then now we have a limitation going up. We don't go up forever. This is the highest we go up. So now remember that vertex is called a maximum. So we already learned in video for number 11 how to find the vertex. When we find that vertex, the x and y coordinate are typically using h and k as variables for, so our vertex would be the point hk. Well, since range has to do with y coordinate, we don't care about the x coordinate of the vertex. We only care about the y coordinate. So the first thing we're going to do is we're going to go into our y equals and type in our quadratic and find the vertex. So we'll go to our y equals, and you need to clear out what you have in there, and you need to pay attention to this sign in front of x squared. Now it's kind of long and it kind of looks like a subtraction, but remember there's nothing in front of it, so we're not subtracting x squared from something. That makes the x squared negative. So type the negative key and then x, and x squared plus 6x plus 1. So make sure you've got it typed in correctly. So now we can find our vertex. Remember, look at the graph first to see whether it's a maximum or minimum. It's at the top, so it's a maximum. So you're going to go to second trace to get the calc menu. This time we want 4. For left bound, it's already on the left side, so I can press enter. I can hit my right arrow to get it on the right side and press enter, and then enter for guess. So that x coordinate is 2.99999, which we know just rounds to 3, and our y coordinate is 10, so our vertex is the point 310. Now remember, we're talking about range, so we don't care about the x coordinate. We only care about the y. So that already eliminates choices A and D, because y, the range has nothing to do with the x coordinate of the vertex. It's going to be 10 in this case. Now we just have to know which symbol to use, less than or equal to or greater than or equal to. Well, since our vertex was at the top, it's the highest that y can be. Y can be 10, but it cannot be higher. So we wouldn't say y is greater than or equal to 10 when 10 is as high as it can get. The correct symbol would be y is less than or equal to 10. So every time you have a maximum, your range is going to be y is less than or equal to the y coordinate of your vertex. Every time you have a minimum, your range will be y is greater than or equal to the y of your vertex.